Hello everyone and welcome back to our channel Quaint Cosmos. Today we are unlocking a mysterious concept that could reshape our understanding of the cosmos. Yes, we are talking about right now dark photons. You know regular photons. Whenever we use the term photons, that means we are talking about regular photons. So you know regular photons, those are force carriers of light and electromagnetic radiation. That is known to you. So those are known as regular photons or only photons. And here we are talking about dark photons. That means this is the dark version of the photons. Dark version of the photons. That way you can describe this one. Actually, you know particle physics, standard model of particle physics. Okay. So actually the concept of dark photons emerged from the extension of the standard model of particle physics, especially an additional U1 gauge symmetry. So that means what? That means dark photons are hypothetical particles. Still there is no practical evidence of the existence of dark photons. Okay, but some theories are there about the dark photons. And if dark photons are discovered, then many unsolved problems could be solved by the use of these dark photons. So first thing is, dark photons do not interact with regular photons. Normally this is said, but this is also said that dark photons interact with regular photons but very weakly. Means dark photons very weakly interact with normal photons or the regular photons. Dark photons do not interact with ordinary matter around us in our visible universe, or whatever we can see with our eyes, all are ordinary matter. So dark photons do not interact with the ordinary matter. Dark photons do not emit light. That means that dark photons are not detectable. Since they do not emit light, they do not interact with the ordinary matter. So dark photons are not directly detectable. If they exist, still we don't know whether they exist or not, because the concept emerged from the theory, extension of the standard model of particle physics. So whether they really exist or not, that is not still known to us or known to physicists or scientists. But if they are discovered, then many unsolved problems could easily be solved, such as the cooling rate of stars, okay, that could be explained. Then behavior of galaxies could be explained. Many things can be explained. Okay, anyway, so I was talking about regular photons. Those are what? Those are force carriers of light and electromagnetic radiation. Similarly, according to theory, dark photons exist in dark electromagnetic field. Dark photons exist in dark electromagnetic field. Okay, and since they interact very weakly with regular photons, and this phenomenon is known as kinetic mixing, so there is a chance that we can somehow detect the existence of dark photons. Such as if you observe carefully the electromagnetic signals, and since there is a mixing of dark photons with the regular photons, then there will be a deviation in the electromagnetic signal. So just by observing or just by detecting those deviations in electromagnetic signal in the electromagnetic field, we can detect the existence of dark matters. Other experiments are also there, like beam dump experiments, like accelerometers. Certain dark matter detectors are there, which are called direct dark matter detectors. Okay, so around the world some experiments are there which are aiming to detect the existence of these particles. Okay, and according to theory, dark photons can be massless, again they can be massive. If they are massive, then there is a chance that dark photons decay into other particles, and those are ordinary particles, means visible particles. So if they are massive, then there is a chance of creation of electron-positron pairs, And electron positrons are what? Those are visible particles. Okay. Positron is the antimatter counterpart of electron that is known to you. Again, muon anti-muon pairs can be, means there is a chance that those things could be created from the decaying of dark photons, muon anti-muon, if they are massive. And if they are massless, or if they have extremely small mass, in that case, either they are massless or they have mass, but mass is extremely small. In that case, there is a chance that those are, means dark photons are long-lived particles. Means there will be no decaying of the particles. Okay, long-lived particles. So many unknowns are still there in the universe. Means we will be able to know the hidden architecture of the universe. We will be able to know. There is a chance after the discovery of the existence of dark photons. And many unsolved problems are there in the field of cosmology, in the field of astrophysics. Okay. Again, many technological innovations could become possible just by the discovery of these dark photons. So that means what? First of all, what is the requirement? The requirement is to find out the existence of dark photons, whether they really exist or not. If they exist, then many things, many unknowns can be solved. Many unknowns about the cosmos. We will be able to know the reality of the universe. You know, this is a great term used in the field of physics to know the reality of the universe. Okay, still we do not know the reality of the universe. We do not know reality of the space, reality of time, or space-time. That is another concept. We still don't know reality of space-time itself. Anyway, so this was all about today's topic, dark photons. If you are fascinated by this video, then please like, share and subscribe to our channel. Okay, this is the end of this video. Thank you. Thank you for watching this video.